In this video, we're going to take a look at some practice Regents problems concerning the rock cycle, igneous rocks, sedimentary rocks, and metamorphic rocks. Okay, so I'm going to go through and put a box around what we're looking for, what the question is asking for. I'm going to underline key information that's provided within the question or within a provided diagram. All right, so this question, we're looking for a name of a rock ultimately. Some important information. We have an extrusive igneous rock, the mineral composition of 35% quartz, 35% potassium feldspar, some plagioclase feldspar, biotite, and amphibole. But the things that stick out, it's an extrusive igneous rock. It is composed mostly of quartz and potassium feldspar. So this is a question about igneous rocks. So we're going to take a look at the diagram on page 7. The very first thing we know is that it's an extrusive rock. So we can restrict our search just to the extrusive rocks contained within this purple rectangle. So since we know it's mostly quartz and potassium feldspar, 70% of those two minerals, we know it is more felsic. Those minerals have more silicon and aluminum in them. So we can draw a line up on the felsic side of the chart. And since we're looking for an extrusive rock, granite is an intrusive rock, gabbro is an intrusive rock, salted glass is on the wrong side, we know we are looking at the extrusive igneous rock rhyolite. This question implements a flowchart. So if you've never read one before, you start at the top and follow the arrows down. So we're looking for the name of rock B. Okay, what do we know about the rock? Besides what's in the flowchart, we know that it has a fine vesicular texture, as composed mainly of potassium feldspar. From the flowchart directly, we can work backwards from rock B. We figure out that it's extrusive, as well as an igneous rock. So we're going to go to our igneous rocks chart on page 6 of the Earth Science Reference Table. And we know it's extrusive igneous rock. We know that it had a fine vesicular texture. We also know that it had a lot of potassium feldspar in it. So it's going to be on the felsic side of things. So we are, in fact, looking at vesicular rhyolite. Here's that same flowchart again, but now we're looking for the name of rock A instead of rock B. And we know that rock A is composed of fine-grained quartz and feldspar particles. We also know the size of those particles is 0.08 centimeters in diameter. Additionally, we know that rock A is a clastic sedimentary rock from the flowchart. So with this information, we're going to take a look at the scheme for sedimentary rock identification, diagram on page 7. And we know that it is a clastic rock, so it's going to be in this upper portion, the inorganic land-derived sedimentary rocks. And we also know what the grain size was, gave us a number, 0.08 centimeters in diameter. So we need to check our grain sizes here. For the first two rocks, conglomerate and breccia, we don't have any numbers, but we do have some descriptions, pebbles, cobbles, and or boulders. Boulders are very large, cobbles are a bit smaller, pebbles smaller still. And as we go down this column, for our clastic rocks, sand is smaller than pebbles, silt is smaller than sand, and clay is the smallest sized particle. Right, our diameter of 0.08 centimeters fits within this range. It's in between 0.006 and 0.2 centimeters. So what are we looking at? We're looking at a sandstone. So rock A is the sandstone. Looking at the same diagram again. Again, we're looking for the name, the identity of rock B. And what we know is that it reacts with hydrochloric acid. We also know rock B is crystalline, and it's a sedimentary rock. And so this is a little bit tougher, but not an insurmountable task. So we're going to start off on the scheme for sedimentary rock identification on page 7, armed with the knowledge that this rock reacts to acid. And we also know that it's a crystalline sedimentary rock. We look at the texture column to determine which rocks are crystalline. So it could be rock salt, rock gypsum, dolostone, or limestone. And then we have to look at the composition column because our clue was that it reacts to acid or dissolves in acid. So armed with this information, we know rock salt's made of halite, rock gypsum of gypsum, dolostone of dolomite, and limestone of calcite. We have to go and check the characteristics of these different minerals on the back cover of the reference table, page 16. So we'll just go down the line. First, we take a look at halite. If we're looking for information about it bubbling with acid, we want to look under the distinguishing characteristics column. Halite has a cubic cleavage and salty taste, as this is what you put on your French fries if you want them to taste good. Gypsum is easily scratched by a fingernail, but it doesn't say anything about bubbling with acid. So we move on. Calcite, very first comment, it bubbles with acid. So let's just take a look at dolomite. And dolomite also bubbles with acid. Difference being, it needs to be powdered first. So you need to powder dolomite in order for it to react to acid. Calcite, put some acid on it and it will start bubbling away. So we're looking for the rock that's made out of calcite. So we identify that in our composition column. We go over, we are in fact looking at a limestone. So how does that fit on our flowchart? We have rock B is a limestone. It's a crystalline sedimentary rock that reacts with hydrochloric acid. Here we're looking for the name of a rock that is formed through contact metamorphism at location A, as well as in location B. Location A and B are in different places. Here is location A. Here is location B. They are going to be different rocks. So in order to answer this question, we need to utilize the map symbols. Location A is in this kind of brick pattern. It matches limestone for the key. B is within this particular pattern, which is a conglomerate. Use the same map symbols on page 7 of the Earth Science reference table. So we're starting with a limestone and a conglomerate. Metamorphism of limestone is going to lead to a marble, and metamorphism of a conglomerate will lead to a metaconglomerate. It's in the name, right? So we're looking at a marble at location A, and at location B, a metaconglomerate. So again, limestone will metamorphose into marble. That's at location A. In location B, we started with a conglomerate, we contact metamorphosed it, and we end up with a metaconglomerate as the metamorphic product. So this question will not require a reference table. This is something that you kind of have to know more or less on your own. So which one of these rocks is metamorphic and why? So we take a look at 1, 2, 3, and 4. I'm immediately drawn to the first one. We can see some deformation, so it kind of looks like it's got waves running through it. And I can also notice banding, so it kind of looks like it's stripes, light and dark, alternating pattern here. So this is the metamorphic rock. And how do I know that? It shows banding and deformation. Example 2 is an example of a crystalline rock. It could be igneous, it could be sedimentary, or it could be metamorphic. So 2 isn't really indicative of any particular type of rock. It just shows that it's crystalline. 3 and 4 are both examples of sedimentary rocks. And so uplift, weathering, and erosion is what we know. We're trying to figure out what they lead to. So whenever we're talking about processes in rocks, you should think about the rock cycle and Earth's crust diagram on page 6. So we are looking for the words uplift, weathering, and erosion because they're processes. They're going to be on the arrows. So I see uplift, weathering, and erosion here, the arrow that leads ultimately to sediments. I see one coming out of igneous rocks saying the same thing, and one from metamorphic rocks saying the same. So uplift, weathering, and erosion will lead to the creation of sediments. In this question, we want to find out which statement about a metamorphic rock is not supported by the rock cycle. Notice that not is double underlined. That's a very important clause here. So we're looking for the statement that is not true. And so we take a look at the rock cycle diagram, and we're starting from metamorphic rocks. We'll go through one by one to see which one of these statements is not true. So statement 1, a metamorphic rock may become sediments. I can see that because I can follow an arrow that says uplift, weathering, and erosion, and I will become a sediment from a metamorphic rock. So 1 is true. 2, metamorphic rocks may one day undergo melting. I also see an arrow for metamorphic rocks that says melting, turn into magma, So 2 is also true. 3, a metamorphic rock has undergone cementation. The only arrows I see going into metamorphic rocks say heat and or pressure, metamorphism. So 3 is our untrue statement. Hopefully this video was helpful. If you have any comments or suggestions, please leave them below.